Now, for another sampling problem, we have here an acidic solution is made by mixing 49 grams of citric acid to make 1,500 grams of solution. So the required is molarity, C is normality, D percent by mass of citric acid, letter E mole fraction of citric acid, and then the percent by moles of citric acid. So the assumptions that the citric acid solution is 1.236 gram per ml. And then just take note that this density is for the solution, not for the solute. And then the molecular weight is citric acid. That means this is for the solute. Okay, the first thing is the molarity. As we know, molarity is moles of solute divided by the volume of the solution. So remember that 1.5 grams here is already the volume of the solution, and then this is the mass of the solution, but the 49 grams citric acid is the mass of the solute. Okay, so for directly calculating it, molarity is equals to moles of solute divided by the volume of the solution. Okay. Now, how to get the moles of solute? That should be the mass of solute over the molecular weight of the solute. So for the mass of the solute, that will be 49 grams. And then the molecular weight is 192.124 grams per mole. So cancel the gram. Moles will be converted and we'll go to the numerator side. So if you're going to calculate this, that's 49 divided by 192.124. So this is 0.255 moles. Okay, so we're just going to find the volume of the solution. So to get the volume of the solution, use density. So V equals to M over density. The mass of the solution is 1,500 grams. Then the density of the solution, this is 1.236 grams per liter. So cancel the grams. You will have, ml. That's ml. Cancel the grams, and then you get ml of the solution. And that will be 1,213.592 ml. Of course, if you're going to go convert it into liters, you're just going to divide it by 1,000. Then it will become now 1.2313 or 14 liters. So for the molarity, you're just going to have this divided by this, the volume. On another page, M, capital M, that's 0.255 moles divided by 1.214 liters. Okay, so that will be 0.210 moles per liter. All right. Now, what it needs now is the molality. So when you say molality, that means moles of solute divided by the kilogram of solvent. However, of course, 1.5, if you convert this, that's 1.5 kilogram of solution. But mass of solvent, just convert it. So that's 1,500 grams of the solution. You divide, you're going to deduct the 49 grams, which is from the solute. This is solution, this is solute. So you will get the solvent. And that will be 1,451 grams. Now, multiply it by 1 kilogram divided by 1,000 grams. So you can cancel the gram, you get the 1 kilogram. So that will be 1.451 kilogram. Now you can get now the M, small letter M, which is the molality. So that will be 0.255 moles divided by 1.451 kilogram of the solvent. So 255 divided by 1.451, that will be 0.176 moles per kilogram of the solvent. Now, the next thing that you're going to kilogram solvent. So the next thing that you're going to get is normality. Okay, but for normality, you need to get the what you call this, the equivalent weight. Okay, you can use this also, normality. N equals to M, the molecular weight, multiplied by the numbers of equivalent. Okay. However, it doesn't show here the numbers of equivalent of the acetic acid. Let's try to check it. Nitric acid equivalent. So I really have to check how many hydrogen that is the equivalent for citric acid. I stand corrected. That's not nitric acid, but it's citric acid. So according to my search, that will be 3. So the N here is 3. Okay. So to get the normality, if you're going to use this formula, you have here 0.210. Then you multiply it by 3. From this one is molarity, the capital letter M. So if we're going to calculate it, that's 0.210 times 3. So the normality is 0.63 equivalent per volume or liters, volume of the solution. Okay, so next question, percent by mass of citric acid. So that's percent by mass. So that means that's 49 grams divided by 1,500 multiplied by 1,000%. So percent mass of citric acid. So 49 grams over 1,500 grams of the solution. this is solute, this is solution, then multiply by 100. And that's 49,1500 times 100. That's 3.267%. Next question. Mole fraction of the citric acid, then the percent mole citric acid. So for the mole fraction of citric acid, that will be mole fraction. So that will be moles of citric acid you divide it by the moles of the solution. So how do you get the moles of the solution? As we can see, the moles of the solution is citric acid, then water, because it's the solvent of the citric acid. So how do you do it? How do you get the moles of the solution? So what you're going to do, that will be the mass of the solute. You divide it by the molecular weight of the solute plus the mass of water with the solvent H2O. Then you divide it the molecular weight of H2O. You add it because you're going to add the solvent and the solute to make it a solution. So mass of the solute, it's 49 grams, and then molecular weight is 192.124. This is grams per mole plus mass of water. Of course, that's 1,500. You minus the 49. That's the mass of the solvent. So that's 1,451 grams. You divide it by the molecular weight, which is 18 grams per mole. That's the molecular weight of water. So cancel the grams, then calculating it. It's 49 divided by 192.124. Then you add the 1,451 divided by 18. So that would be 80.866 moles. Okay, so mole fraction. So you get the moles of the solution. The moles of the citric acid is, where is it? This one, 0.255. Okay, 0.255 divided by 80.866. So the answer for the mole fraction, it's 0.00315. Okay, so that's the mole fraction. No units because it's a mole fraction. And the next question here is what will be the percent by mole citric acid? Okay, so you're just going to multiply this answer, the mole fraction, by 100. So that will be the percent mole of the nitric acid. So that will be 0.315%. Okay, so that will be the second example. Thank you.